For today's video, we will verify some trigonometric identities. So secant x minus cosine x equals sine x multiplied by tangent of x. This is the first one. By the way, this question is suggested by one of our followers. Now the second identity that we need to verify is this identity. Cotangent A plus sine of A over 1 plus cosine A equals cosecant of A. Now, let's start with the first identity. Alright, so to verify this, what we're going to do is, again, let's get the left-hand side and let's manipulate this until we reach that they are the same thing. Okay, so what I'm saying is like this. So let's start with cosecant x minus cosine x. Now, to verify this kind of trigonometric identities, my technique is to replace all other trigonometric function into sine and cosine. The reason is sine function and cosine function are easy to handle than the other trigonometric function. So what we're going to do is to replace this secant x. Now take note this identity. Secant of theta must be equal to 1 over cosine of theta. So we can replace this secant x with 1 over cosine theta. So this simplifies to secant x becomes 1 over cosine x. Alright? Now, on the right-hand side of our equation, we will use some algebra. We need to make the denominator the same. So what we're going to do is to multiply this cosine x over 1 by cosine x over cosine of x. And if we do that, we get cosine squared x over cosine x. Now, since we have the same denominator, we can now combine them. So if we do that, we get 1 minus cosine squared x over cosine x. Now at this point, we will use another identity, which is the Pythagorean identity. So sine squared theta plus cosine squared theta equals 1. Now take note, when we subtract cosine squared theta on both sides, we get that sine squared theta equals 1 minus cosine squared theta. So 1 minus cosine squared x must be the same thing as saying we have sine squared x. So using this Pythagorean identity. Now at this point, using some algebra, we can break this sine squared x with sine x multiplied by sine x. Now your question, why we need to break this sine squared x into sine x times sine x? Because on the right-hand side of our identity, we have sine x. So let's make this sine squared x become sine x multiplied by sine x. Now, we have again sine x, so we can separate this sine x and we need to multiply this by sine x over cosine x like this. And for the last identity, take note the sine theta over cosine theta must be equal to tangent of theta. Therefore, we can replace this sine x over cosine x with tangent of x. And there you go. The first identity is verified. So secant x minus cosine x must be the same thing as sine x multiplied by tangent of x. Alright, so how about this second identity? So let's start. Again, we need to replace all other trigonometric function in terms of sine and cosine. So cotangent A using this identity. Using this identity, cotangent theta equals cosine theta over sine theta. Therefore, we can replace this cotangent A with cosine of A over sine of A. So this cotangent A becomes cosine A over sine of A. Next, what we're going to do is to combine these two fractions. Why not? Notice that our goal is to make this cosecant of A. Alright. Now, to make these two denominator the same, what we're going to do is to multiply sine of A with 1 plus cosine A over 1 plus cosine A like this. So now, our denominator becomes sine A times 1 plus cosine A. So on the other fraction, what we're going to do is to multiply this by sine A over sine A. So we have sine A times sine A over sine A times 1 plus cosine A. Now, the denominator is totally the same, so we can now combine them. Let's add the numerators and copy the denominator. Now, on the numerator, we will use some algebra. So let's distribute this cosine A with 1 and cosine A. So if we do that, we get cosine A plus cosine squared A. Now, if we multiply sine A multiplied by sine A, this will give us sine squared A. And we can now use some identities, specifically the Pythagorean identity. Take note, when we have sine squared theta plus cosine squared theta, it must be equal to just 1. So, cosine squared A plus sine squared A, this is just 1. Now, cosine A plus 1, we can rearrange this because addition is commutative. So we can say that it's the same thing as 1 plus cosine A. Now, we have 1 plus cosine A on the numerator, 1 plus cosine A on the denominator, so we can cancel those factors. Now, what will happen on the numerator? We have left with 1. So the right-hand side becomes 1 over sine of A. Now, for the last time, let's use this identity because we know 1 over sine of theta must be the same thing as cosecant of theta. Therefore, 1 over sine of A must be the same thing as cosecant of A. There you go. This identity is now verified also. And as always, we are done. Now, for your practice, verify this identity. Sine theta multiplied by tangent theta plus cotangent theta equals secant theta. Now, if you have your answer, just comment your complete solution in the comment section down below. Bye for now.